The Royal Academy of Science International Trust interview with computing scientist Dr. Patricia Ordonez.
My name is Patricia Ordonez. Where am I from is a complicated question. But I guess right now I'm in Maryland, in Columbia, Maryland. But my family is actually from Colombia, South America, from Bogota, Colombia. So I feel like I'm from both places. My academic preparation, I have a PhD in computer science with this, and the title of my dissertation was the multivariate time series of physiological and clinical data, multivariate time series data analysis of physiological and clinical data. No, and it didn't have the data word. And the focus of my research at this time, it's actually grown. It's not just multivariate time series and medical data, but I actually have worked a lot with data science, with biomedical data and with, biology data, looking at, circadian rhythm of bees. I've worked also with computer science education and also with assistive technologies. And so this, the focus of what I'm going to be talking about today is one of our ways of trying to create more accessibility to analyzing clinical data. And I've done visualization too of multivariate time series data.
Sound of multivariate data.
In medicine, we have this problem where we treat, especially I work in critical care. So critical care, and specifically with babies. So it was, it's called neonatal critical care. And a lot of the babies are very fragile and they're premature. And if you can imagine a baby coming out of, being warm and in the heart and, in the belly, and the sounds that they might hear in the belly, where it's like their mother's heartbeat and things like that. And they come out, and what they hear is, it's really like the machines that are surrounding them, that are measuring them. There's lots of machines that measure, babies, especially critical care babies, because you want non-invasive things. Although people don't consider sound as invasive, but I think it is. And one of the interesting studies that they did at Hopkins, when I was working with them at Johns Hopkins University in Baltimore, they actually found that they felt that physicians, in terms of OSHA in the critical care, the amount of noise from the machines, the alarms that go off with the machines, was actually going against the OSHA standards. And OSHA standards stand for like the standards of too much noise that they use actually, typically for construction sites, airports, where you have just a lot of noise. There's only a certain amount of noise that is healthy. And they found that the amount of noise that was in critical care units was not healthy. And that was not just for babies, but also for adults. And so the whole idea of using sound that could do two things. I wanted sound that physicians could hear that an alert was coming, but it wouldn't upset the patient. And then the other idea was, I wanted it to represent. So I've always thought of like when your body is working well, it's like a symphony. It should sound like a symphony. And because if everything's going well, then things are, in order. But when things go wrong, then it must sound like when something's out of tune in a symphony, and we can feel that, right? And so that was basically the idea. I'm still working with. I'm trying to get the data. We're still working, on the IRB process with the new hospital, and still working with Johns Hopkins University, but just trying to work on the ARB process and get the visualization established, because the idea is create the visualization with the music, and see if with the visualization and the music we can we can learn more about patients of the patient. So that's the idea right now. But so we're still in the IRB stage, which, as you know, in medicine, it's when there's two universities and the data belongs to one university, that has taken a little bit longer than expected. But we're going to hopefully start in the summer. So I'm excited about that. I mean, ideally we can create just an environment that, you know, I just imagine going into a room of a patient and that the sounds are more healing. You know, I don't know if you've listened to those. You know, there's music that I listen to for when I want to concentrate. There's music that I listen to when I want to heal. And it could be that maybe a patient has a favorite song or something like that. So you go in, you hear the music, and so that normally doesn't happen because the physicians have to hear like the alarms. But the physicians could be listening to something else, and you know, with that basically plays, you know, some sort of an overlay of the music, and you know, with the music they can know what patient it is. I mean, but really right now it's so much in the beginning stages that I don't know, but they have shown that music has helped people heal, and that brings them memories, that brings them good things. So I think that incorporating some kind of music into that environment, and being able to incorporate some sort of data, some messages about data through that music would be phenomenal. But that's very, very futuristic. But I'm lucky to at least have partners that are open to that. So it's very good. And actually the people that I work with are at the University of Pennsylvania. And so in the, you know, in the Department of Translational Medicine. So I'm really trying to look at, now we've created the visualization. We do want to do a little bit more AI with analysis, and then how can we incorporate those two things with the visualization and the AI into translational medicine research, not translational medicine, translational research, so we can apply in the hospitals. Multivariate time series, that's the case. Like when I diagnose the patient, it's not just with one variable. You do much better with one or two variables or three, not too many. We've also found that if it's too many variables, they have to be very targeted for what you're looking for. But with a few variables, you can make very, very good diagnosis. And so it's just knowing which ones have the most impact. And I think that's going to be the hard part with sound, because sound, you know, can come from everywhere. How do you highlight the variables that are important, or features if you're thinking about machine learning, like and for what you're looking for, and like how do you give them different sounds, or should there be a standard sound? Like normally when you do visualization, you always want to keep certain, like you create the visualization, you have each axis, and it should be something that people see regularly. And so we're experimenting now with, you know, the physiological data, and there's basically like six physiological signs that they look at, vital signs that they look at, which are like respiratory rate, systolic blood pressure, diastolic blood pressure, respiratory rate, SaO2, which is the blood, the oxygen saturation levels, and I can't remember what the sixth one is. But so they have a whole access to themselves, and so then it creates shapes that you can recognize. So in our case, it's like, do we want to look at just those 6 parameters and give each one a different, you know, instrument? Would that be? We even discussed it. Would it be good to give it a different instrument, and that way you know which one it is? And can you just make music from a body, and when it that could tell us when the body is going downhill or not working well in unison. And medicine is a very traditional science, right? And it's it's slow to make changes to that level, right? Even with visualizations, it uses the traditional visualizations, and what they've added more than anything is like being able to interact with the visualization in terms of like selecting the parameters, take them off, put them on. But the visualizations that they use are still the very traditional XY axis, that kind of thing. And so that's one of the things that I think with medicine probably makes it very difficult for, even though we might experiment it and find that it's successful, for implementation to happen, it takes a long time. So, well, you know, it's medicine is not an exact science, right? People like we have to see it as something that complements it, and what we have as the alternative right now is not good at all. It's like these alarms that go off on, you know, with they, you know, they just go off when the emergency is already happening. So there's no sense of that the emergency is coming. And so having music that maybe distorts or something like that, we also talked about that, using distortion to indicate, you know, when something starts to rapidly change. And so that, you know, we talked about, okay, we have this baseline that we know is normal. When everything's in the baseline, then you play the music normally. But then when something starts to go really wrong, then we start hearing that it's not playing the song so normally, and so it gets a little bit distorted, something that the physicians would probably be able to notice, or people in the room would notice, but not the patient who's sick that much. And that could give us an alert much earlier. You know, you really don't know who will have an allergy, who will have, you know, how the people will react. And so physicians basically try and then see if it works. If it doesn't work, then they stop and they switch to something else, right? That's the way medicine works. So it's not an exact science. And so putting something else into the mix, like music, is and you know, physicians are used to working in a certain way. And so anything that is a change that would be that drastic would really, we'd have to prove that it significantly improves the environment, and then go from there. So I think that's kind of like the tradition of it, the fact that it's not an exact science, and the fact that, you know, we're talking about human lives at stake, right? So people who are in the hospital are typically very ill, and so just doing experiments of people that are that vulnerable is not something that that people adopt. So there has to be experimentation prior, and so having clinical trials for something like this would make it really, really difficult. Actually, if you, I think the more you work with people who have disabilities, first of all, the more you realize the loss, how much loss of potential there has been over the years. And when you look at like if the potential that is lost, in the sense that, imagine if we basically gave everybody the ability to reach their full potential and incorporate them, you know, it could be that there's maybe one person who could hear this when nobody could hear signals that nobody else could hear. If we would just give people the chance to be included. I don't know. My niece did a story about Louis Braille that I never knew. He was brilliant, and he basically he heard about the fact that they were using, you know, signals to do messages, and then that they had come up with a system, and he came up with a system that he thought would work for him, and he spent lots of time doing it. And but he lived in a home for the blind, right? Before, we used to just put them put people who were blind in institutions, and the health standards of those institutions were not very good, and so the lack of him, he died at the age of 24. And I think to myself, like, what if we had listened to him? He had to fight for because even when he invented it, people kept discrediting his invention. Instead of working with him, they would come up with alternative forms of Braille. and the one that worked the best for people who were blind was Braille. And so for me, it was it's a story that we see over and over again, that if you know, we need to be more inclusive in science. I also think of, like, for example, with Marie Curie. You know, she wasn't allowed to study. She came from Poland. Her name was Maria Sklodowska, right? And so what she did was she became an au pair, taught herself a lot of the basics of math while she paid for her sister went off and she paid for her sister's education in France. And then when her sister was finished, then her sister brought her over. So she really started in the university at the age of 24. And it wasn't at the Sorbonne. She was at another university, and then wanted to do research at the Sorbonne. And then she met her husband, and they did fantastic research together. And there's so many of these people that are lost in, I mean, Marie Curie is one of the most renowned, but like she's so famous. Like she's actually it just, to me, it demonstrates how exclusivity. She died at the age of 42 due to radiation causes. And when you read about the conditions of her lab, they weren't healthy conditions. And we see this in a lot of places that are, you know, we don't help. And, you know, I say this also because I see what's happening at University of Puerto Rico and other institutions that are, you know, they don't have the funds. They're not giving the funds that they need to be successful, and to give everybody access to a very high quality science education. And I just think that we are constantly, by not being more inclusive and not prioritizing sciences, we're not bringing the best to the table, right? We're bringing the best from certain populations and the best from certain economic levels to the table. And we really need to be much more inclusive if we really want to reach the high levels of science that can tackle serious problems in our society. And we also have to do more interdisciplinary work, right? We have to give validity to, you know, disciplines that are outside of the sciences. And that's where, you know, working with these musicians was such a treat. And so I went off a little bit, but I think it all ties together, that the importance and inclusion of people of all abilities, of all, just to see that everyone can contribute to science in some way, and we have to find a way to make everybody be included and experience science, so they can decide whether this is, and feel included, like they belong in science, even if, you know, they end up being in some other field. But I think science just gives you this learning about. I never felt like I belonged in science when I was young. And it wasn't until I was an adult that I actually got into sciences, when I started to realize that you know, it's the whole concept of experimentation and how you do research, and I think we should do that, give everybody an opportunity to do that. I really didn't have, my first opportunity to do research was in graduate school, and I think everybody should have that opportunity, even from high school. So I guess my answer is, I do think everybody should be included, and multisensorial practices will help make the field much more inclusive.
A final message by Dr. Ordonez.
Basically, the two things, I think multisensorial research will enhance research. So I think it will improve data analysis in any field. And the more we can develop multimodal ways to analyze data, I think the more we can be inclusive and the more we will get more participation from people. And if I could say one more message that is a little bit distracting from this is that someone told me as an adult, because I think when I was younger, I listened too much to people telling me, no, this is probably not for you. You're not. And I would say to everybody, if you are interested in the sciences, even if you feel like you don't belong, don't let anybody else define you. You need to define yourself. And I think you're